everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today we are going to discuss about SAS Macro Series Part 7B. If you remember, earlier we had Part 7A wherein we have discussed about macro quoting functions. In Part 7B, we are going to discuss about evaluation functions, %sysfunc, and character-based macro functions. Now let us discuss about various types of macro functions. There are four types of macro functions. The first one, the quoting function which I have mentioned in here, we have discussed in detail in our earlier videos. Now coming to evaluation functions, what these functions do is they give the numerical ability to a macro variable so that you can do calculations with macro variables. And the next one is character macro functions. These are very similar to regular SAS character functions, but these are macro functions. And the next one is by using %sysfunc, we can use datastep functions itself as macro functions. About each of these functions, we will go in detail in coming slides. First, let us start with evaluation functions. Before going into the evaluation functions, we need to understand one important thing, or I would like to reiterate one important point in here. Everything and anything in a macro variable is a text. I have been repeating this obscene number of times, but I think this is a very important point to remember. So that's why I repeat it over and over again. So whenever we are going to create a macro variable, in here I am saying %let a equal to 10 plus 2. Everything in here is text. None of them is treated as a number or anything else but as text. So when we want to do a %put and we want to look into the value of macro variable, what we will get is we will get a equal to 10 plus 2. And again, I have discussed about %put ampersand equal to macro variable in my earlier videos. Please have a look into if this is something new to you. But in short, whenever we want to do a %put, we can do ampersand equal to, and this will show the result in the log as a equal to and the macro variable value. Here the macro variable value is 10 plus 2. But what if we want to do some kind of calculation in here? Then we are going to do one thing, that is we are going to tell that please treat these values as numbers and this as a mnemonic operator wherein you can do plus in here. So this %eval tells the macro system to treat these values as number and this as operator, and then when we do %put ampersand equal to b, we get the value of 12. Not only plus, we can do other things also. In here I am doing %eval 10 multiplied by 2, and this gives the value of our macro variable c to be 20. So %eval gives the ability to do some calculations. In here we have explicitly used %eval and we were able to do some kind of calculation in here. Actually, there is one important point to remember is not every time we have to use %eval, but some of the conversions happen automatically. Now let us look into an example for that, and this is known as implicit or implied %eval. About this I have discussed in one of my earlier videos, and link for the same I will give in the description below. But let's also quickly try to understand what is meant by implied %eval. In here I have a macro. In this macro I am defining my macro variable %let z equal to 2, and also I am doing a %do loop in here wherein I am saying I equal to ampersand z plus 2, percent 2, 10 plus ampersand z, percent by ampersand z. And I am also saying to put the value of this macro variable in here, and then I am ending this do loop in here, and finally I am ending my macro in here by using percent %men. Before going into any other details, now let us try to understand what is happening in this percent do loop. In this percent do loop, we are creating a macro variable I, and in here we are saying ampersand z plus 2, which is our starting point, and we are saying our ending point as 10 plus 2, and also we are saying that to increment by 2 because our macro variable z has a value of 2, and we are also trying to put the value of this macro variable I after every iteration, and then this loop ends when it reaches this endpoint. Now let's compile this macro by running the code from percent macro to mend the macro by running percent %ys, and after executing the macro, this is the result we see in the log. Now let's try to understand what we see in the log in here, and in here you can see that the value of I is 4. What does this mean is this ampersand z plus 2 became 4, and the starting point is 4, and we are doing a percent put, that's why we have 4. And once this iteration is completed, in the second iteration it increments by 2 and becomes 6, and then again increments by 2, 8, and then again increments by 2, 10, and again one last time it increments and comes to 12, and 12 is our endpoint in here. So what I wanted to tell you in the whole of this thing is, even though we are doing addition here without percent eval, the addition is happening. And this is known as implicit or implied percent eval. Here I want to tell you one thing. That is, even though we have not used percent eval, in certain scenarios, the percent eval runs behind the scenes and it does all the calculations. And this is the one of the scenario which I am showing you in here. Now let us quickly move on to another topic. Even though percent eval is very useful in giving numeric ability to the macro variables, it has its own limitation. Especially it is very limited when we are trying to use any macro variables which have decimals. Now let us look into an example and try to understand it better. Here I am saying percent let a equal to 10, and then herein I am doing percent put ampersand a plus 1.2, and I'm also doing percent put percent eval ampersand a plus 1.2. Here ampersand a plus 1.2 gives 10 plus 1.2, that is our ampersand a gets resolved to 10, and then we have 1.2, and we also have the plus symbol in here. Here it is a simple straightforward macro variable property. But when we are trying to do a percent eval and then trying to do the calculation, we get an error saying that a character operand was found in percent eval or percent if condition 10 plus 1.2. So it has a problem with this decimal. Now to address this, what we can simply do is we can use percent sysevalf. And when we do percent sysevalf and then we say ampersand a plus 1.2, it gives us 11.2. Now we have discussed our evaluation functions. Now let us move forward with character-based macro functions. Character-based or text-based macro functions are very similar to datastep functions, but they work on macro variables and text. Now let us look into an example and let's try to understand what is different in here. So first let's try to create a macro variable. In here I am saying percent let n equal to hello world. and I'm doing a percent put and I'm saying value is at, and in here I'm using my percent index function. This is very similar to index function what we use in datastep. And in this function, my first argument is my macro variable ampersand n, and then followed by comma, and my second argument is world. That is, I want to find the location of world in this macro variable. Obviously, the macro variable value is hello world, and we are trying to find where world is. There are two different between macro functions and also our regular data step functions, especially related to character based functions. The first one is pretty obvious, that is, whenever we used macro functions we use a percent symbol in front of the function. And the second one is more important and subtle. That is, whenever we are trying to do an index function in the data step, when we have two arguments, the first argument, what we do is we usually use our variable, and the second argument, what we do is we use some kind of character value and we put them in the quotes. And when we compare that to our percent index function, we again have two arguments. Here the first argument is generally macro variable, and the second argument here will be a text. We don't put any quotes in front of it because we are searching for this particular text in this macro variable. And if we try to put quotes in here, what happens is this will try to search the word along with the quotes and it will never find it. So an important thing to remember here is we are trying to check for a text in here. And I think instead of telling character based macro functions, I should have probably used the word text based macro function. Now, after this, let's look into what happens to our result. It finds the word world at the 7th position. This is again very similar to our data step index function, but we are using on macro variables and comparing with the text. Now let us discuss another aspect of macro functions. For every regular macro function, there is a quoting macro function related to it. Now let us try to understand this through an example. And for this example, let us take percent upcase. To understand percent upcase, let's create a macro variable. In here I am saying percent let h equal to my world. And in here I am doing a percent put and using a percent upcase on this macro variable h. And you can see here that in the result we have my world upcased. That is, by using percent upcase we were able to upcase the value of macro variable, and there is nothing special about this. Now to understand Qfunctions, let's get into another example. In here I am creating three macro variables, macro variable a, b and c, and for a we have the value of test and for the b we have the value of semicolon. To pick up the value of semicolon into the macro variable, we need to use %str. I have discussed in lot detail in my earlier video about %str and how quoting functions work. And now also I have another macro variable c equal to hello. Now after creating these three macro variables, I want to do upcase all these three macro variables. Before going into the details of this percent upcase, please check out my video on quoting functions wherein I discuss about %str in detail, and link for the same I will give in the description below. And another thing is, if we would have not used %str here for the semicolon, what would have happened is this %let would have ended here. That is where the semicolon is there. And what would have happened is it would have had no value in here. But for this macro variable b, we want the value of semicolon. So this %str, what it does is it helps to treat this semicolon as text. Now let's get into our percent upcase. In here I am doing percent upcase on three macro variables together at one time. And what I am doing here is I am saying percent upcase, and in the parenthesis I have ampersand a, ampersand b, and ampersand c. Once we run this percent put statement, this is the result we see in the log. In here we see that ampersand a value test is upcased, and also ampersand c value hello is upcased. But we also see an error. The error at this point is because whenever we are starting our percent put statement, it ends with a semicolon. Because ampersand b is semicolon, our put statement ends in here, and hello seems to be something which is not related to this percent put statement. That is why we have an error in here. To avoid this kind of error, all we need to use is percent %q upcase. What this does is it does upcase and also it does quoting. And because of this quoting, it masks the semicolon, and the semicolon is treated as text. And when we do this percent put, now we don't see any error in here. Regarding the coding functions, I have made a very long video of close to 45 minutes, and link for the same I will give in the description below. Now let us look into the last topic, that is using data step functions with the help of %sysfunc. We can use most of the data step functions with the help of %sysfunc, except very few like input function, put function, lag function, and others. Now let us look into some examples to understand this better. In here I am creating a macro variable %let name equal to smith.john. I want to create another macro variable x, and what I want to do is I want to have the macro variable value of name, that is smith.john, but I also want this dot to be changed to underscore. Transvert function is one function in datastep which locates a particular character and it replaces that particular character with another character. We can use the transvert function in this %let statement by simply using a %sysfunc followed by our transvert function. In here we are saying %sysfunc, and we are starting a parenthesis, and then we have our transvert function. For this transvert function we have again a parenthesis, and then we have our three arguments, and this parenthesis is closed, and this is for our transvert. These three arguments are nothing more than, first is macro variable, the second one is the character we want to replace, and the third argument is what is the character we want this to be replaced with. We want to replace dot with underscore, so here we have dot and here we have underscore, and finally we close with another parenthesis for this %sysfunc. If you remember simple data step functions, we have transvert and all of this set. Only new thing here we are doing is we are using %sysfunc, and then we are having a parenthesis start and parenthesis closed. In this fashion we are able to access transvert function from datastep into our macro facility. Now another important thing to remember here is I do not have quotes around this dot or underscore because everything here I am dealing is with text. Here I am not dealing anything particular with character variables or anything. That's why we don't have any quotes here. If I have kept a quotes in here, what would have happened is this would have looked for in this particular macro variable for quotes and dot, and that is not what we want. And once we have created this macro variable, we can simply use %put statement and see the result, and the result we can see that result is Smith_John. So %sysfunc is helping us to access datastep functions very easily. Now we have used one of the character functions of datastep. Now let us try to use one of numeric datastep function. Again, pretty straightforward, pretty same. All here I am doing is I am creating three macro variables k1, k2, k3, and I am having the value of 10, 22, and 55. And what I want to do is I want to find a max value from these three macro variables, and I can simply do with the help of max function followed by my three macro variables which are my arguments for this max function. All again I need to do is I need to add a %sysfunc, parenthesis enclosed with the parenthesis. Now I am able to access the max function, and when I do the %put for this macro variable, I can see the value as 55. So in here we are able to easily access numeric functions of datastep also. Now let us go further ahead and try to understand how to nest these functions. We have done these kind of things in datastep, or we do these kind of things in datastep quite often, wherein we have to use more than one function on a particular scenario. In here, what I want to do is I want to do two things. The first thing is to find the max value within these three macro variables, and whatever the max value I get from these three macro variables, I want to do a mean, and that mean I want to do with a value of 10. So first I can simply do is %sysfunc, and then max value I can find it out here like this. This we have seen before. And here, as we can find our max value by using %sysfunc and the max function of datastep, to do a mean is again also super simple. All we need to do is we need to modify very little bit. That is, we need to do one more %sysfunc, and then I need to mention mean, and then I need to start a parenthesis 10 comma, and I need to have this %sysfunc for max value. So this nested %sysfunc on the max will give me the max value, and in this case it is 55. And once we have this value, the second %sysfunc is applied and we get our result of mean, that is 32.5. So the important point I want to mention is this is very similar to datastep, wherein we have to use multiple functions. What we simply do them is we nest them. We can also nest %sysfuncs, and then we use our functions very similar to what we do in datastep. Now let us look into what else we can do with our %sysfunc. We can also apply formats by using putn and putc function. One another thing I want to remind you is we cannot use put function with %sysfunc, but we can use putn and putc. Putn allows to apply numeric format, whereas putc allows to apply a character format. Now let us look an example for both of this. In here I am doing %let c1 equal to 22281. This is a numeric value, even though this is a text, and we can apply a numeric format by doing a %sysfunc followed by putn, and then we are using our macro variable c1 which we have created here, followed by our format, that is ddmmyy10 dot, and this is a numeric format. And we are also doing %put to see this value in the log, and once we run these three lines of code, this is the value we see in here, that is 01012021. So by using %sysfunc and putn, we were able to apply format to this value, and we have applied here numeric format. And also we can apply a character format also. To apply character format, we need to use putc. In here we have a macro variable b, and we are saying hi, how are you as a part of this macro variable. We can do a %put, and here what I'm doing is I'm using %sysfunc put c, and then I'm applying this on macro variable b, and in here the format I'm using is upcase 14 dot, and here you can see that once we run this piece of code, we have the value hi, how are you, and the value is upcased. So we have applied the formats to display the data we want it to be. I'm not going to discuss about what is a format and any details about putn and putc because we are majorly concerned about %sysfunc and what it can do for us. If I go into the details of format and all those things, it will become a long video on itself. Now let us look into some informats. We can apply informats by using inputn and inputc function. And now let us look an example for both of this, that is for inputn and inputc. Here I am creating my macro variable b1 by saying %let b1 equal to 01 backward slash 01 backward slash 2021, and then I am creating another macro variable and wherein I am saying %let b2 equal to %sysfunc, and I am applying here input n in format, and here I am using my macro variable as my first argument, and in here I am applying my informat. And once I apply this informat and create this macro variable and use a %put, and once I run all of this code, I see the value as 22281. Now, here we have used informat. Informats are mostly to read the data. Formats are to display the data. I don't want to go into details of this, but if you want to do something and want to change the macro variable appears, you can do it. You don't have to go to datastep and do it, but simply you can use %sysfunc and use putn, putc or inputn. Now let's also look into one example of inputc. Inputc allows us to apply character informat. In here I have macro variable %let a equal to quotes hello world and quotes close semicolon. And what here I am doing is I am doing a %put, and here I am using %sysfunc. Followed by it I am using inputc and applying a character informat, and in here I am saying $12 dot, and my first argument is the macro variable a. And once I run these two lines of code, I see hello world. If you see, we have started with double quotes around, and by using this particular informat, now we have hello world without having any quotes. So I have gone through briefly on formats and informats and how you can change the values of your macro variables with the help of them. Now let us go ahead and look into one application of this %sysfunc, and I will also discuss about a quoting sysfunc, and then we will wrap up this topic. In here I have a macro. What this macro does is we are trying to see whether a particular file exists or not. If it exists, we want to read it with the help of proc import and create a data set. If the file itself is not there, then what we want to do is we want to say that the particular file is not there. And in here we have a parameter that is our file name parameter. What we will do is whatever file we want to check, we can just pass it as parameters. Again, we can do whole of this with the help of %sysfunc. Here I am writing %if %sysfunc, and in here we are using a datastep function file exists on macro variable file nm, and then I am closing my parenthesis %then do, and in here we are doing two things. The first thing is we are giving a file name statement which is as follows: file name followed by a file ref and the location of the file in the parenthesis. As I said to you, this file is comes from our macro variable, and that macro variable is file nm. And once we have used this file name statement, this file ref we are using in the proc import, And in here we are also creating a data set. And this part ends here with the percent end. If we do not have the file here, we are saying else percent do percent put this file ampersand file name does not exist percent end percent meant. So once we compile this macro, we can execute this macro by saying percent file checking and then passing our file name in here. And if you see in here, the dataset was created because this particular file was there. And in the same macro, if you pass a file name which is not there, we are going to get the message that this particular file does not exist. With the help of %sysfunc, we were able to use datastep function file exist, and also by creating a macro we were able to automate a process. This process, what it does is it checks whether there is a particular file or not, and if it is there it will create a data set. If it is not there, it will tell us that particular file is not there. And now let's look into our last topic, that is %q sysfunc. And we can understand this with another example. In here, I am creating a macro variable wherein I am saying %let x equal to %nrstr, and then in here I am having %proc a, %proc b. If I do not use %nrstr, I may get a warning saying that %proc a and %proc b macros were not there. And now what I want to do is I want to use %sysfunc and datastep function substr and want to extract something from this particular text. What I want to extract is %proc a. So what I am saying is %sysfunc substr, and then I'm using this macro variable itself, and then I'm saying that to extract starting from 1 position to 6th position. So what it does is it extracts this particular value. But when we run these 2 lines of code, we also get a warning. This warning says that apparent invocation of macro proc a not resolved, means it is looking for macro proc a, because whenever we execute macro we simply give a % and macro name. To avoid this kind of thing, all we need to do is we need to use %q sysfunc just instead of sysfunc, and then we can use our substr and %x, 1, 6. And when we run these 2 lines of code, now we are not going to see any error, but we are going to see the value of %proc a in the log. In here, what I wanted to tell is whenever we use datastep function and sysfunc, and if we feel that we have some special characters and we need to mask them, we can simply use qsysfunc. And in here, I'm not going to go into any details regarding how quoting works and what quoting does, but I have made a very long video on that, and link for the same I will give in the description below. That's all for this topic. If you like this topic, please give it a thumbs up, share and subscribe. Thank you.